Hi, in this video we're going to take a look at glomerular histology. Histology is the study of the microscopic anatomy of cells and tissues. So we are going to be looking at the glomerulus really close up. I'll start by drawing a glomerulus. So the blood flows through the glomerulus via these arterioles, entering through here and exiting through here. The blood is filtered in the capillaries inside the glomerulus and the filtrate flows out here. The glomerulus is surrounded by the Bowman's capsule, which is made of epithelial cells, which we call parietal epithelium. Epithelium is one of the four basic types of tissue, the others being muscular, nervous, and connective tissue. And epithelium lines the surfaces of structures of the body. Now between the parietal epithelium and the capillaries we have Bowman's space. This is the area into which filtrate collects before flowing into the proximal tubule. As we discussed in the last tutorial, these are the afferent and efferent arterioles, and they can constrict and dilate in order to regulate the rate of filtration, known as the glomerular filtration rate, or GFR. And like all blood vessels, these arterioles are lined by endothelial cells, not to be confused with epithelial cells. They are a completely different type of cell and have a different embryological origin. Now this area here is the beginning of the proximal tubule, and it has these characteristic brush border epithelial cells, presumably to increase the surface area of the cells. And this allows for greater reabsorption and secretion of solutes and water. Between the two arterioles is this distal convoluted tubule, which is rising up towards us at right angles with the plane of the page. And here, covering the capillaries, we have a cell called the podocyte. It's called a podocyte because it has feet, and pod means foot in Greek. And these are also a type of epithelium. We call these visceral epithelium. We'll talk more about them later in this tutorial. Between the distal convoluted tubule and the glomerulus, there is a highly specialized group of cells called the juxtaglomerular apparatus. Again, not to be confused with the juxtamedullary nephron, which is something else entirely. So I want to talk about the juxtaglomerular apparatus because it is super important. There are three cell types in the juxtaglomerular apparatus. The first are granular cells, and they produce renin, which is the start of the renin-angiotensin-aldosterone system, which is really important in controlling blood pressure. For more information about this, see the handwritten tutorial on the renin-angiotensin-aldosterone system. The second type of cell is a macular denser cell. This is a cell that detects how much sodium chloride is passing through the distal convoluted tubule and sends a signal to the granular cells to release renin. There are also these extraglomerular mesangial cells, but the function of these is contentious. Now I want to talk about the capillaries within the glomerulus. I'm going to take a cross-section through here and draw what we might find down here. So there are three types of cell involved here. The first is the capillary, which again is an endothelial cell. And these are attached to mesangial cells, which are like the scaffolding for the capillaries in the glomerulus. They can actually contract and relax to alter the glomerular filtration rate. The third type of cell is this podocyte, which we saw before, covering the whole capillary network. These prevent large molecules such as albumin from being filtered by the kidneys. And they too can contract and relax to increase the gaps between them and increase and decrease the glomerular filtration rate. And that's an overview of the histology of the glomerulus.